So we're not going to spend a lot of time talking about applications of integrals. That really is a topic for second semester calculus. But I do want to hit on a couple of things. One thing that I want to discuss is this idea of the mean value or the average value of a function. Now, of course, I'm sure you all know how to calculate an average, right? You add up the values of all of the items in a data set, and you divide by the number of values. Well, that works. We're talking about a finite data set. When we're talking about functions, these functions are what a statistician will call a continuous variable. They can take on infinitely many values between a certain range. How do we handle that? Well, you know, when we talked about our definition of an integral, of a definite integral, we said it's kind of like an infinite sum, right? In a sense, the integral between a and b adds up all the function values between a and b. So in my formula here for the average value of a function, the integral is taking the place of the finite sum, and this b minus a, that's the length of the interval, right? That's the distance between a and b. This is taking the place of the n, right? So this is a formula that we're going to use to calculate the mean value or the average value of a function on a certain interval. All right, so let's see how we can do this, right? I want to find the mean value of this function on this interval. So this really is just a question of using my formula, right? This is a, and this is b, and f of x is, of course, my function over here, 2 plus 1 over x. So let's put these numbers in here. The average value is 1 over 3 minus 1 times the integral from 1 to 3 of 2 plus 1 over x dx. All right, so let's see. This first part, this is just 1/2. And let's see, I need an antiderivative here. This is 2x plus the natural log of x evaluated from 1 to 3. And let's see, now I'm going to put my numbers in. I'm going to use my fundamental theorem. Right, this is 2 times 3 plus the log of 3 minus 2 times 1 plus the log of 1. All right, so now it's just a little algebra simplifying. This is 1/2 6 plus the log of 3 minus 2, right? Because the log of 1, that's 0. So this is 1/2 times 4 plus the log of 3, which is 2 plus 1/2 the log of 3. And that's it. That's the average value of this function over this interval. Okay, so let's see. I want to show, I'm going to show something here, right? I want to show that the average value of a constant times a function is equal to the constant times the average value. Everything we've seen, so, derivatives have this property, limits have this property, integrals have this property. So I want to show that my mean value has this property. So here's what I'm going to do. The average of k times f is 1 over b minus a, integral a to b, k f of x dx. All right, but no, look, I'm going to use one of my integral properties. I'm going to take that k, I'm going to bring it out. I'm going to make this k, whoops, there we go, k over b minus a times the integral from a to b of f of x dx. And then let me group this just a little more. Let me bring the k all the way out in front and make this k times 1 over b minus a, integral a to b f of x dx. But this bit here in the brackets, that's just the average value of f. And that's what I need to show, right? We can bring a constant out in front and just kind of let it ride out there in front, bring it back in at the very end. Okay, so we're a very, very simple application, right? Not getting really fancy at this point. Like I said, we're going to get really serious about doing things with applications of integrals in second semester calculus. So where are we going next? Well, the next thing we're going to talk about, we're going to look at finding the area between two curves.